Welcome to the short discussion on the topic types of beams and loads on beams. This is part of the shear force and bending moment chapter, which is one of the unit in strength of materials 1 course. So, in this particular short discussion, the targets that we kept uh, uh, by the end of this particular session, we are hoping that maybe at least reach these targets, that is identify the beams based on the supports provided. So if you have been given a picture of practical impedance, you could look at it and you could able to say that this is the kind of beam that is shown, right? Similarly, you could be able to mark out the reaction components at the supports of that particular beam that was given to you, and also you will be able to show the magnitude and the orientation of the different loads that are acting on a beam. Let's see how far we can reach these targets. So our topic is types of beams and loads on the beams. So before going to the types of beams, let us try to understand what is a beam first of all, right? So what is a beam? The beam is in general defined, it is, of course, everybody knows, it is one of the structural member, right? Beam is one of the structural member uh, which carries the nature of that particular beam. No, we define based on the what functions it carries. Based on that, we are going to define it. So it is a structure, basically a structural member, but it always carries the loads in a direction perpendicular to the longitudinal axis. This is the longitudinal axis of the member, right? This is the member, this is the beam, this is the structural member, and this has the longitudinal axis like this. And if it carries loads, right, in a direction perpendicular to the longitudinal axis, right, or it can also be said as transverse to the what you call longitudinal axis, right? So in simple words, you can define a beam a structural member which carries loads in a direction perpendicular to the longitudinal axis of the member is called a beam. That's all, as simple as that. Okay, a structural member which carries the loads in a direction perpendicular to the longitudinal axis of the member. This is the perpendicular, this is the longitudinal axis direction, and the loads are acting in this. So they are normal or not? Yes, they are normal. This is the direction of the longitudinal axis, this is the action of the loads, right, in which no, the loads are acting. This is the direction. So this direction is perpendicular, right? So once defined the beam, right, how it was classified, there must be some basis, right? So the basis for the classification of the beam is so these 5 points we have considered. There may be some other no basis based on which we can classify, but here only 5 factors are considered. What are those? One is supports, right? A beam is supposed to rest somewhere. Later on we will see what is that support and how that beam is classified based on the support. So based on supports, then geometry, right? So this beam geometry is one basis for its classification. Shape of the cross section, how the cross section look like. Okay, based on that also we can classify the beams. Equilibrium conditions, right? So there are set of equations in order to keep the particular object in equilibrium. So based on the available number of equations also we can classify the beams. Then materials, what material, no with what material it was made of. So based on that also we can classify. Let's look at now. Take one by one. Let's say based on supports. So as we said, this is no, in building, this is the structural member, right? That was carrying loads in the transverse direction. So in building we will say this structural member which carries loads in transverse direction is called beam. In bridges we may call either beam or sometimes may call it as a girder. Okay, you might have seen somewhere while you are traveling on the road. Then we are discussing on the classification based on the supports. Let's see what is a support first of all. It is also a structural element. Just as the beam is a structural member or structural element, support is also a structural element. Okay. But what its function is, it is a resting place for the beam. So the structural element that acts as a resting place for the structure or beam, or any structure it can be for that matter, for any structure is called a support. In our case, it is the support is a resting place for the beam, right? So a structural element which acts as a resting place for the structure is called a support, right? Now we might have seen this kind of support somewhere. This is a kind of support under the bridges. You can see this kind of arrangement of the support. So this whole member above is resting, this member is resting on this beam or girder is resting on this particular support, right? Similarly, sometimes you may be fixing here some kind of bolts and it is kind of steel structure. This is a beam member, and you can either use a welding process to connect them, to fix them, to support them. Okay, or you can use a bolting system, or you can use a rivets. Anyway, you can make it a support at the desired location. Okay. So these are no different types of supports you can say. This is a kind of support. This is a door. This is a member door, and this was pinned somewhere. And you can no move in this direction. You can close the door and no what you call open the door. That means you can subject that pin to the moment. Okay. Similarly, here ground itself is acting as a support. There is a pole, electrical pole. It was no it was no just buried into the ground. Okay, that particular ground is a resting place for the particular pole, electrical pole, right? So now we got a preliminary understanding about the support. What is a support? How many different types? Maybe here itself I have shown almost no four different types of or three different types of supports. Right? This is a kind of a roller supporting system. The pin or hinge. Sometimes it's called hinge. Pin support or hinge support, where a door is no attached to the frame, right, by means of that kind of support. And here this is a no it is fixed or clamped to the ground, right? Or here the members or a stanchion column member and beam members are attached together. They made it as one unit by making is the welding process or bolting or riveting. So this kind of clamping or fixed conditions are provided here, right? So three different support conditions are. In general, we deal with mostly there may be some other types of supports in both strength of materials and even structural analysis, or for most of the design cases we deal with only these three types of supports: fixity, fixed support, hinged support, and a roller support. All right. Now, when we have different types of supports like this, those three types of supports, a hinged can be represented. How these supports are represented? Roller can be represented in any of these forms. Either it can be a single roller like this, a ball, or two rollers kept like this, or a socket ball kind of arrangement, right? This kind of arrangement. This is all these are representations of the roller support. So when you want to represent roller, you can use any one of these kind of ways to represent a roller. Either a single ball, a double ball like this, kind of circuit ball arrangement or this kind of one. Then here is another one. Here is a pin support, kind of triangular wedge shaped. Okay, so wedge shaped here, and then this is called pin or hinge. There is called either hinge or either this way you can represent, or this way, or even this way you can represent. Right? Any of these forms you can pin support can be represented any of these forms. Fixed support can be represented this fashion. Okay, it's our clamped support can be represented this fashion. Okay, and kind of you're simply resting the member on a particular surface, that can be also called a simple support. Okay, so now having understood the representation or idealization of the supports, how the reaction components can be represented for these respective supports. A roller in reaction components are nothing but the kind of resistance offered by the specific supports. A roller can offer resistance to the beam, right, in the direction perpendicular to its perpendicular to the surface, right. So this is resting on a horizontal surface, so it offers a resistance perpendicular to that surface, so that this way it offers resistance. So always we should remember a roller will offer resistance or reaction, okay, in a direction perpendicular to the surface on which it is resting. That's it. Then coming to the pin, a pin has a resistance. Here there is no resistance to the horizontal direction, we should remember that. If you move it, it moves. So there is no resistance. So one single reaction will come when you are taking a roller support. When you are putting a pinned support, a pin can offer resistance not only in vertical direction perpendicular to the surface, but also in the horizontal direction. Okay, in this direction also it offers rest. It cannot move when there is a hinge. You cannot move either horizontally or even vertically. Like we have seen that example door. Can we move this door this way? You cannot move. Or we can move this way. Either we cannot lift it, or we cannot no pull it either front or back. We cannot either lift up and down, or we cannot move either front and back. It cannot be done. So it has resistance both in y and in the sense horizontal and vertical direction. But you can move it. That means for a moment there is no resistance. Then kind of fixity. Fixity means it is resistance from all sides. No, you cannot move horizontally, you cannot move vertically, you cannot even rotate also. So all kind of resistance, right? Fixity means all three directions. That is, x direction you cannot move, y direction you cannot move, you cannot even rotate, which means in the z direction. Okay. So that is no. The summary of this is the representation of the supports is like this. Namely, roller can be represented any of these forms, and pin support can be represented any of these forms, and fixed support can be represented like this, and simple support can be represented like this. The corresponding reactions components are like this. For a roller 1, pin 2, fixed 3, that is horizontal, vertical, and also moment, and then there is a simple support called frictionless surface. One single reaction can keep. Now once we got an understanding about the supports, so to support beam, except fixed support, we may have to use at least two supports, because it has to rest. The beam has to rest safely. Okay, so except fixed support, we have to use combinations. Okay, so these combinations here, no, we can use any of the combinations, maybe a roller and a hinge. Okay, or you can use either fixed and roller. Of course fixed support can be used alone also, right. And fixed and hinge you can use, fixed and roller you can use, or you can use two hinges also, right. Generally one hinge and one roller is used, right. So based on this combination of the supports, the beam may be called with different namings. For example, I am using for the resting this beam, I am using two kind of supports, one hinge and one roller. Then it is called simple support or simply supported beam. If I am using only one fixed support, that is called cantilever. It's called cantilever beam. One side it is only fixed, the other side is free. Such a kind of beam is called cantilever beam. And if the same two hinges also I can use, such as this, I simply placing the beam over the supports and with some extra projection. That means there is a projection left on the left and right side. That is a kind of beam called overhanging, because there is a hanging portion additionally, right, on both sides. So it's called overhanging position. It may be sometimes overhanging on one side, or it may be overhanging on the other side. Okay, this part of the beam is called simply supported beam. Just totally it is called overhanging simply supported beam, right? Then fixed beam, if both supports on either side you are using a clamp or a fixed support, it is called a fixed beam, right? So now sometimes you may be using more than two supports also, it may be required. So it is not that always we will be using only two supports, so you may require more than two supports also. So when you are using more than two supports, such a beam is no, the beam which is resting on more than two supports is called a continuous beam. Okay, so this is the classification of the beams based on the supports, right? When you use a combination of the hinge support and roller support, it is called a simply supported beam. Or when you are using only fixed, so two fixed supports on either side called fixed beam, only one fixed but the other one is free, then it's called cantilever. When it is resting on two hinges but with some overhanging portion on one side or other, both sides, then it is called overhanging beam. And then if you are using more than two supports, maybe two hinges, sorry, three, more than two pairs, three hinges, or two hinges and one roller, or one fixed and two rollers, or one fixed and two hinges, like that. Any of the combinations, keep on adding. So right after more than two supports, you can add any number, maybe even 50 or 100, doesn't matter. But that beam is called continuous. Okay. Now one classification is over. The next one, what was the next classification? It is based on the geometry and cross section. Based on the geometry means the members are no, made up of either straight direction or some kind of curved nature, or some kind of tapered way, right? So when you and the beams are straight, the cross section remains perfectly straight, right? So then this is called a straight beam. And when you are making the beam in a curved manner, it's called curved beam. And when you are using the cross section, keep varying from point to point, at some location it is having maximum thickness, and keep reducing that. Okay, so that kind of beams are called tapered beams. Now based on the cross section, right, the cross section can be made in different phase, right? This is the cross section that you can make either an I shape, or you can make it an L shape. Okay, either two L sections may be maybe joined together, or two channels may be joined together. Okay, or a T beam alone can be used. So depending upon the cross section, like I section or T section or L section or channel or U or kind of halo rectangular sections, all these kind of sections are possible to made. Basically in steel, this kind of cross sections are available, right? So this is based on the kind of the classification based on the geometry and the cross section. Now we reached the last but one, that is equilibrium conditions and the materials. The materials is quite straightforward. Now you can classify the beams based on the materials with which they are made. Either they can be made of timber, or it can be made of steel or concrete, or any other type of material. So accordingly you can call like a steel beam or aluminum beam or concrete beam or timber beam, like that. You can use any of these names. So coming to the equilibrium conditions or equilibrium equations. So generally there are no equilibrium equations. We all might be aware of that, right? So there are three equilibrium equations that we all know. That is sigma fx equal to 0, right? If it is a two-dimensional problem, there are three equations. Say sigma fx, sigma fy, and sigma mz equal to 0. Okay, these are the equilibrium equations. So generally for a two-dimensional problem, you will be having these conditions, right? Three equilibrium equations. So if your reaction components, unknown reaction components, are equal to these in number equal to these equilibrium equations, then it is called a determinate beam. If not, it is called statically indeterminate beam. For example, you take a simply supported beam. A simply supported beam will have how many reactions, right? So there is a horizontal vertical reaction, and because the hinge, right, we have two reactions here. Is a roller, for example, then it will have total three. So three equations, three unknowns. That means this comes under the category of statically determinate structure. Okay. Similarly, cantilever has one free end, one fixed end. So at fixity you have all three reactions: horizontal, vertical, and also a moment. So again 3 and 3. So this is also comes under determinate structure. Whereas the fixed support, here 3 reactions are available. Here also 3 reactions, total 6. So available equations are only 3. So that means the number of unknowns are greater than the number of equilibrium. That means this comes under the category of indeterminate structure. Also this one, right, the continuous beam. Suppose the continuous beams are available with all hinges, right? So two equations are available at all the supports. Okay, providing it is a general kind of loading, there are 6 available, and then you have only 3 equations available. That also comes under indeterminate structure. So this is the classification of the beams based on the equilibrium conditions. And then, so that's the first part of our discussion: how to classify the beams based on the supports geometry and cross section, equilibrium conditions, and materials. Then go to the next one. The next part is the what are the various load, because after all beams are meant for carrying loads only. So we should be having knowledge of the loads also, what type of, how many types of loads are there, how they will be acting on the beams. We should be having this kind of knowledge. So often when a structural member or beam is loaded, it may be loaded in different ways, such as, suppose there is a beam where are bags, either rice bags or cement bags kept like this. Then this, how to represent such kind of loading, right? It was actually distributed uniformly, you see, right? You can put any number, doesn't matter. Okay. So these are distributed, uniformly placed, right? So such kind of loads can be represented this fashion. This is called uniformly distributed load. The loads are uniformly distributed. Okay. Then here this kind of situation comes. For example, you are there is a vessel and there is water inside that particular uh, vessel. That is a water, or you can, or water or some other kind of material you kept, right? Maybe soil kept on that. So now if you look at the kind of loading acting on this vertical member, try to draw the member, the loading intensity on that comes in this fashion, uniformly varying. At the bottom you will have a largest intensity. As we move to the top, it will be less. So this kind of loading will be acting. Similarly, when you are applying a huge load, that is a considerable magnitude load at a small, no, on a small area, you are acting. The load is acting or placed at a considerable load is kept on a small distance. Such kind of loads are called point loads or concentrated loads. They can be represented this way. So it was concentrated at a particular point. This, so considerable amount of load acting on a small distance is called point load, right? And then when it is spread over a large distance, the load is uniformly spread out over a large distance, is called uniformly distributed. Now the sometimes the two equal and opposite loads are acting separated by some distance, such as a kind of pulley here, and there is a load applied here, the right, and through another pulley, right? These weights are now keep moving, right? So you can increase the load or you can increase the load here. This will create a kind of couple, right? Or it's called moment, right? So to equal and opposite loads acting at a specific distance, they are going to create a kind of couple, and that is represented this way. This can be either this direction or even this direction. Okay. Even the Loads may not be always mostly it is vertical, in the sense downward. It may be sometimes upwards also, right? Similarly here, this UDL may act upwards. This one also may act upwards, but most of the times it is in a vertically downward direction. This is how you represent different loads acting on the beams. Okay. So so in the practice, no, in the practical life, the loads acting on the pressure vessels, aircraft structures, underwater structure, metal form techniques, all these kind of situations, these kind of loads only no, you may have to deal with, right? Finally, the applications of the beams, where you are, you know, using the beams in different locations. It may be in buildings, if you see it, to support the roof floors and ceilings, right? And in bridges, you are maybe using as a decks of the bridges, right? Similarly, there are some vertical type of structures like, you know, poles and all. When you are designing such member, you are also designing that members as beams only. Particularly, you are dealing with towers or chimneys, a kind of aircraft structures. No, they are fixed at one location and they are subjected to the loads in a direction perpendicular to the longitudinal axis. All those members are also analyzed as well as designed as the beams only, right? Because it was, they are fixed at one side, they are treated as cantilever beams, right? So that's all the targets that we kept for this discussion. That is, we could able to now identify the beams based on the supports provided, whether it is uh, a cantilever beam, which means fixed at one side and free at another side, and then two, one hinge and one roller is there called simply supported, and they are, there is having some kind of overhanging part or projection from the supports. Such kind of beams we are calling as overhanging beams. And then when more than two supports are there, that is called a continuous support. And then we could able to mark the support reactions, right? And finally, loads can also be easily represented along with the magnitude and direction or orientation, right? And there are some other questions for our no, improving the understanding, like different levels, either with remember or understanding level. You can just refer to these questions. What is the function of the beam in a building? Define the distributed and concentrated load. Recall the types of supports for based on different conditions we told, right? And then how they are classified on, you know, based on the supports and cross based on the geometry, different conditions we talked about, and how to represent the components, support reaction components for the various kind of supports. And then few examples that are used, analyzed and designed as cantilever beams or continuous beams, right? Here is a tower, there is a chimney shown, here is a retaining wall, right? Like that. Similarly, there may be kind of kind of thoughts may be coming whether the beams are always necessary in a building. May not be. Sometimes we don't use any building, any beam. Directly we can rest the floor onto the columns. They are called flat slabs, right? So this kind of similarly, what kind of beam cross section you can use in rail, what you call rail girders, they are called tracks, right? Mostly it used a high kind of cross section of beams, and gantry girder also will maybe a combination of I section and channel section is used. So these are some additional information given on beams. Thank you.